Real numbers and the number line. Algebra, Chapter 1, Section 3. Probably the easiest way to explain a perfect square is to look at some examples. 2 times 2 equals 4. That means 4 is a perfect square. 3 times 3 equals 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. 7 times 7 is 49. 49 is a perfect square. Next, I'm going to list some numbers. I would like you to try to pick out which ones are perfect squares. Take a moment and look at these numbers. Can you find the perfect squares? One is a perfect square because 1 equals 1 times 1. 100 is a perfect square because 100 is 10 times 10. 121 is a perfect square. 11 times 11. 16 is a perfect square. 4 times 4. 289 is a perfect square. 17 times 17. So a perfect square is developed when a number is multiplied by itself. Why are they called squares? Well, they're called squares because when you're looking at 1 times 1, which equals 1, that's 1 times 1. Another way of writing that is to write it 1 squared. 4 times 4, 4 squared. 10 times 10, 10 squared. 11 squared, and 17 squared. Since these are written with the squared sign, or raised to the second power, we consider them squared. A square root is basically the opposite of a square. Go ahead and write this definition down. This should be in your notes. Now, how do you determine what the square root of something is? Well, you think about what you would multiply by itself to get that number. When you consider 36, you think to yourself, well, 6 times 6 is 36. So 6 is the answer. That is true, but it's only one of the answers. Because if you remember your negatives, negative 6 times negative 6 makes a positive 36. So another possible answer is negative 6. And you see here that I've written it two different ways. So for the square root of 81, you have the possible solution of 9, but you also have negative 9. For 49, you have the square root of 49 equaling 7 and negative 7. I've told you to write this definition in your notes. If you don't quite understand this, make sure you write down a few examples as well. Not all square roots are perfect squares. Sometimes we need to estimate the square root of a number. Now in today's age, we use calculators or our phones and can figure out the exact value. But mentally, it's important to be able to estimate a value. When estimating a square root, you try to find two perfect squares that it fits between. As you see, 34 sits between the perfect squares of 25, which is 5 times 5, and 36, which is 6 times 6. So estimate-wise, we realize that the square root of 34 is not over, but it's kind of close to 6. And I chose 6 because 34 is closer to 36 than it is to 25. So to estimate this, I look at something in that range, like 5.7. And I multiply 5.7 times itself. And as you can see here, it equals 32.49, which is pretty close. But let's see if we can get closer. Looking at this, you can see that I multiplied both 5.8 out, squared it and multiplied it out, and I squared 5.9 and multiplied it out. And as you can see, the 34.8 is a plus 0.81, and the 33.64 is minus or under 34 by 0.36. So your closer estimate is 33.64. So your actual answer is 5.8. To estimate the square root of 34, you would look at 5.8 as the answer. As you can see here, this is a number chart. We will create a foldable very similar to this to put in your agenda. Looking at this number chart, I want you to realize that natural numbers is a group of numbers that doesn't include 0, but it's your typical counting numbers, 1, 2, 3, 4, 5. When you move to whole numbers, it includes all of the natural numbers, but also the number 0. Now, the next larger group, which means it includes all the natural numbers and all the whole numbers, are the integers. The integers are all the positives and all the negative whole numbers, 1, 2, 3, 4, 5, plus the number 0. We also have rational numbers. Now, rational numbers includes all the natural numbers, 1, 2, 3, 4, 5, etc., the whole numbers, which is the natural numbers plus 0, the integers, which are the natural numbers plus 0, plus other negatives. And it also includes fractions and decimals, with a bit of an exception. The decimals must be either terminating or repeating. Here are two definitions that I hope you write into your notes. The first one is rational number. It is any number that can be written in the form of a fraction, integer a over integer b. Only b must not be equal to 0. A rational number in decimal form will either be repeating or terminating. Irrational number. This is the number that's the opposite of a rational number. It cannot be represented as a quotient or a fraction. In decimal form, irrational numbers do not terminate, nor do they repeat. Irrational numbers include pi and any square root of a not perfect square. Here is problem number 4. Take a look at these numbers. Put a check where you believe each one belongs. And remember the chart where you have natural numbers, then whole numbers, then integers, and then rational numbers, and then in a separate space you have irrational numbers because they're the opposite of rational. Another activity for you to try, and we will check this and number 4 tomorrow. And here you are going to place each of the numbers above, -7, -5.43, 0, 3/7, pi, and the square root of 7 in the box below. Number 5 has been placed for you. And I will see you in class tomorrow.